It was 2:30 in the afternoon in the South China Sea. An American MH-60R Seahawk, the U.S. Navy's rugged multi-role workhorse, hovered just above the waves, dipping its advanced sonar array into the ocean. Below them, a Chinese Type 039 diesel-electric submarine was attempting a risky maneuver, trying to recharge its batteries after spending 48 hours submerged and silent. Suddenly, the sky tore open. A Chinese Z-10 attack helicopter screamed toward them, its orders clear: warn off the Americans and force them to leave. What Beijing didn't know was that this routine act of intimidation would backfire spectacularly. Over the next 72 minutes, the People's Liberation Army would hand the U.S. a masterclass in its own failures. The Z-10 is a helicopter that looks fierce, but its design has a critical hidden flaw. Developed with Russian help in the late 1990s, it has always been desperately underpowered. Its WZ-9 engines produce only around 930 kilowatts of power each. To put that in perspective, the U.S. Apache helicopter's engines push out over 1,700 kilowatts. In the hot, humid air of the South China Sea, where engine performance degrades, this power deficit is a fatal weakness. As military aerospace expert Douglas Berry of the International Institute for Strategic Studies has pointed out, the Z-10 has always been held back by its weak engines. He notes that the helicopter has been plagued by propulsion issues, which severely limits its performance and what it can carry into a fight. And it showed. The Chinese pilot flew aggressively, firing flares and diving across the Seahawk's nose at a distance of just 500 meters, demanding the American crew change course, even though they were 50 nautical miles from any Chinese territory. The American crew didn't even flinch. They remained calm, methodical, and professional. Because while the Chinese pilot was trying to get a radar lock, the Seahawk's sophisticated AN/ALQ-210 electronic support measures suite was doing something incredible. It was collecting every signal the Z-10 emitted. Its radar frequencies, its communication bursts, even the unique vibration harmonics of its rotors. Every move China made was being recorded, analyzed, and instantly sent up the data link to the entire U.S. carrier strike group. This is where the encounter turned from a tense standoff into a complete humiliation for China. As the Z-10 pilot finally thought he had achieved a radar lock, his cockpit display suddenly filled with static. Nearby, an unseen U.S. Navy EA-18G Growler, a jet built for electronic warfare, had activated its powerful ALQ-99 jamming pods. Instantly, the Chinese pilot's world fell apart. His radar screen was flooded with ghost contacts, 12 phantom targets that were moving backwards, sideways, and in impossible patterns. One ghost target even appeared inside his own cockpit. The jamming was so total and disorienting that U.S. operators who reviewed the data later called it a full hallucination event. For the U.S., it was an unplanned but perfect live-fire electronic warfare trial. For China, it was a disaster. The pilot was flying blind. His most advanced systems rendered useless in seconds. According to Brian Clark, a senior fellow at the Hudson Institute and a former top aide to the Chief of Naval Operations, this is where the U.S. holds an almost unfair advantage. He explains that while China is building ships and planes, the U.S. has mastered the electromagnetic spectrum, giving it the power to blind and disrupt enemy forces from a distance before a single shot is ever fired. While the Chinese pilot was lost in a digital phantom zone, the American crew turned the encounter into one of the most productive intelligence harvests of the year. The Seahawk's sonar never stopped tracking the submarine below, and the moment the Z-10 screamed in, its aggressive presence forced the Chinese submarine commander to make a panicked decision: to dive immediately. This emergency dive caused violent cavitation around its propellers and pressure pops from its hull, making it acoustically light up like a Christmas tree. Suddenly, a submarine that had been trying to stay hidden was now broadcasting its exact location and acoustic signature to the entire U.S. carrier group. In just 72 minutes, one aggressive Chinese pilot handed the United States more actionable intelligence than some collection programs gather in years. The Seahawk sensors cataloged every single electronic secret of the Z-10. They recorded the radar pulse patterns and frequency hops used by its fire control system. They captured the precise infrared signature of its WZ-9 engines, which burned at an exhaust temperature of around 450 degrees Celsius, and the heat from its transmission housing, which ran at 180 degrees Celsius. Let me tell you, this isn't just random data. This is the exact information that the seekers on American heat-seeking missiles like the Stinger and Sidewinder need to achieve a perfect, undeniable lock. The U.S. systems even recorded the Z-10's rotor harmonics, the unique sound print of its blades spinning. With this data, U.S. listening posts and submarines can now identify any Z-10 from up to 50 miles away by sound alone. Even the Z-10's communications betrayed its weakness. Its encrypted radio frequencies still use a 2003-era Russian-style modulation. The pattern was so predictable that U.S. algorithms could reportedly decrypt the pilot's transmissions within hours. By the end of the encounter, the U.S. knew everything: the Z-10's radar model, its software version, and even how to spoof its laser designator. In short, one overzealous pilot handed over the electronic vulnerabilities of an entire helicopter fleet. Throughout the standoff, the Seahawk's door gunner stood ready at his GAU-21, a 50-caliber machine gun capable of firing armor-piercing incendiary rounds over 2,000 meters. He never fired a shot, but the weapon was a silent reminder. If this were a real combat situation, the Z-10's thin aluminum skin would have been shredded in an instant. The Chinese pilot tried so-called thumping maneuvers, pitching and rolling his helicopter to bait a reaction, but the Seahawk simply outlasted him. Pushed beyond its limits, the underpowered Z-10 effectively flew itself into mechanical failure. The hydraulic pressure in the Chinese helicopter began to drop, its controls grew sluggish, and its powertrain overheated, pushing beyond 105% of its rated capacity. By the time the Chinese pilot finally broke off and retreated, he was likely nursing a critically damaged aircraft. And Washington had its proof. China's frontline attack helicopter is no match for the layered electronic warfare and superior endurance of U.S. systems. The same pattern of failure that China exposed in that humiliating cockpit encounter has now cost it hundreds of millions of dollars and its credibility on the global arms market. In July of 2025, the Kingdom of Saudi Arabia quietly suspended its tests of a $100 million Chinese HQ-17AE short-range air defense system. The reason? It failed spectacularly during live-fire drills outside the capital, Riyadh. The HQ-17AE, which is exported by the Chinese state-owned company Norinco, was pitched as a next-generation rival to proven Western systems like the American NASAMS and the German IRIS-T. It was supposed to be the centerpiece of Beijing's affordable alternative sales pitch to the global south. But when the Saudis put it to the test, it was a disaster. This kind of failure fits a pattern that experts have been warning about for years. Peter Wesemann, a senior researcher on arms transfers at the Stockholm International Peace Research Institute, notes that while China offers cheaper alternatives, many countries have discovered their equipment suffers from poor reliability and performance, especially when compared to proven Western systems. The system missed a staggering 7 out of 10 drone and missile targets. In one particularly embarrassing failure, it completely failed to even detect a simple commercial-style quadcopter drone flying at low altitude. Saudi technicians who leaked the results were blunt. The system's radar refresh rate couldn't keep up with modern drone swarms. Its advertised engagement range of 20 kilometers, or about 12 miles, was effectively only 12 kilometers in the hot, dusty conditions of the desert. To make matters worse, its command vehicle completely froze mid-test due to a software lag. The system was bundled with Chinese-made missiles that cost around $1.2 million each, meaning every miss was a costly failure. After the drills, Riyadh reinstated the U.S.-made Raytheon systems and quietly postponed any additional contracts with China. For defense analyst Richard Bitzinger, this outcome is no surprise. He says that for nations who need weapons that work every time, American systems have a key advantage. They are combat-tested. He explains that U.S. hardware has an established track record of performance under the most demanding conditions, a level of trust China simply cannot offer. This wasn't an isolated incident. Throughout 2025, multiple countries that had bought into China's sales pitch reported similar reliability issues. Pakistan and Myanmar found that Chinese radar systems underperformed badly in high humidity and heat, the exact same conditions the Z-10 faced in the South China Sea. They discovered that the electronics in China's missiles degraded far faster than their Western equivalents, and crucial replacement parts took months to arrive. Analysts now estimate that China's defense export backlog exceeds $25 billion, much of which is caught up in disputes and delays over poor performance. The message is clear. China's arsenal for the global south is cracking under the pressure of real-world use. From the tense skies of the South China Sea to the dusty deserts of Saudi Arabia, the events of 2025 have exposed a deep and undeniable pattern. China can mass-produce impressive-looking military hardware, but it cannot mass-produce trust, reliability, or real-world combat performance. Analysts at the RAND Corporation have a term for this exact problem. They describe the Chinese military as being hardware-rich but software-poor. What they mean is that China excels at building impressive machines, but it critically lacks the software, the skilled operators, the realistic training, and the institutional experience needed to win a modern war. A single, overconfident Z-10 pilot handed the U.S. a complete blueprint of his aircraft's weaknesses, from its engine performance to its secret communication codes. A $100 million Saudi arms deal exposed China's premier air defense system as a mirage, unable to perform even basic tasks under pressure. Both of these failures showed the world that Beijing's much-hyped military rise isn't just being watched. It's being recorded, analyzed, and countered in real time by a technologically superior and more experienced United States. The world is taking notice, and the lesson from these disasters is simple and devastating for China's ambitions. Technology without experience is just a weapon pointed back at its maker. And in the high-stakes arena of global military power, China has just shown that its most advanced systems can't be trusted when it counts the most.